our 6th session today. Our talk is about using Druid for network monitoring and trust analytics at Cisco. And our speakers are TJ Julie and Abhishek Radhakrishnan. So TJ is a principal engineer at Cisco. He's worked on production web services with a focus on data engineering and analytics for the past 6 years and worked with Druid in production for the last 5. And Abhishek is a software engineer at Cisco. He uses Apache Druid to provide analytics at Crosswork Cloud and is also an Apache Druid contributor. So without further ado, I will let you gentlemen take it away.
Cool. Thank you, Rachel.
You're welcome.
Hi everybody. Thanks for joining the virtual summit today, and thanks to Imply for organizing and then also pivoting to keep something going here. This is really cool and some really great talks so far today. So Abhishek and I will be talking about a couple different projects at Cisco that use Druid in production. So just a bit about structure of the talk. I'll go over a couple systems. First system would be Intersight, the second Crosswork Cloud, which Abhishek and I are associated with. Abhishek will go into some of the technical details, and then we'll both finish out with kind of some of the lessons that we've learned over the years working with Druid. So if we could go to the next slide, please. Okay, so starting out with Intersight, this is a project that when I first came to Cisco, I started working on. Intersight is a SaaS service that customers use to manage their Cisco UCS servers and their HyperFlex deployments. And so obviously, there's a real need for customers to actually understand, how are their servers performing in the wild, and getting, real-time updates is really, really key. So obviously you'll see this as kind of a theme throughout this talk. What customers want to be able to do is deploy their servers and see how they're doing. And so Abhishek, if you could go to the next slide. So this is a dashboard that a customer can see. Before Druid, Intersight would basically just display kind of the current status of a server without any kind of like notion of history or anything like that. But now you can see that we're collecting things like network port byte counts, temperatures, fan speeds, energy consumed, stuff like that. And the UI allows you to both see at an aggregate level across, perhaps your thousands of servers deployed, or drill down into specific servers to really see what's going on. Next slide. So just a bit about, kind of the scale of the system as at this point. There are upwards of 490,000 servers connected to Intersight right now. Ingestion's kind of bursty. It's all Kafka ingestion. At peak, it's around like 220K, with the average being more like 20K. And Intersight for quite some time now has been using the native batch jobs to do re-ingestion, to basically roll up data older than a week. Next slide. Okay, cool. So now to switch gears to the project that Abhishek and I are currently working on, Crosswork Cloud. So this is another one of Cisco's SaaS products with two kind of main pieces. The first being network insights, and the second is trust insights. For network insights, provides customers, usually network operators, with visibility into the internet at large, trying to understand like what does the state of the internet routing table essentially look like. And most importantly, it allows operators to see how other parts of the internet view them and how their network views other parts of the internet. And we do this by peering with a lot of geographically diverse peers in different localities, ingesting network routing data, and then displaying it to customers. So this is really important, and also it's extremely important to get real-time, up-to-the-minute updates, because there's actually a lot of kind of hijinks and tomfoolery in the internet today. So a lot of folks will just have routing misconfigurations, or even just like actual legitimate security-related attacks that disrupt their network. And so the sooner that someone can see this and understand the nature of the failure, then they can react and attempt to fix the breakage. So we can go to the next slide. So here, this is just like a random, part of the UI. Here, we're just looking at, one of the peers, and we're seeing a time series on the bottom there with, how many prefixes my peer is advertising. So again, here, it's super important to be able to understand in aggregate data from, wide swaths of the network, but then also to be able to drill down and get really deep into the data. Okay, next slide. Okay, so now a companion piece to Network Insights is Trust Insights. And this product is a tool that allows network operators, again, to understand the security posture of their network devices that they've deployed into their network. So Trust Insights is in field trials now, and we expect it to go GA at some point in the near future. But basically, the product allows you to see like what is actually installed on all of my network devices on my routers, down to the software package as well as hardware. So I can look and see, hey, did I deploy that fix for this, compromise that we just found out about? Or have I deployed, X hardware or Y hardware? But again, it's really important for network operators to understand kind of like how their network behaves in aggregate and, again, drill down. The way that we collect this information is using a secure, essentially essential system that's rooted in a hardware root of trust, so basically a TPM that's installed in the network devices. That data gets pushed up into the back end, and then it gets, through some ETL, pushed into Druid. So next slide. So again, just kind of random UI time series information. Boom. So just a quick bit about the backend, and then I'll turn it over to Abhishek for more details. We are deployed in AWS, and we are a multi-tenant SaaS. And Abhishek is going to talk a bit more about how we deal with that, because that's kind of an important aspect of some of our architectural decisions. For the back end, most of our services are coded in Golang, and the front end is TypeScript. We use Kafka to tie all of our services together. Pretty much all information flows through Kafka. And indeed, we are using the Kafka ingestion for real-time into Druid. Our primary message serialization format is protobufs, and our API and inter-service communications are gRPC. And with that, I'll turn it over to Abhishek.
Thank you, TJ. So here at Crosswork Cloud, Druid serves a variety of time series use cases, including peer metrics, trust inventory change log, software and hardware changes, internet routing updates, and alarm historical events, and so on. Prior to using Druid, we used Foundation DB, a key value data store, for some of these applications. So now that we've looked at what our backend kind of looks like, this is in particular the ingestion piece that interacts with Druid. We have applications ingesting real-time streaming data to a set of Kafka topics. An ETL application consumes these events from the topics and performs validations on the incoming data. The incoming data is structured and hierarchical. So any transformations are applied to break the structured data into denormalized protobuf messages. Also, any optional pre-aggregation is done prior to ingestion. During the ingestion phase, the flattened out protobuf messages are serialized as JSON blobs and are finally emitted to a topic. We also track the ingress data quality with logging and metrics. Any invalid data that is detected in the pipeline is dropped to a Kafka topic for further forensic analysis. On the other hand, all the valid data that Druid consumes from is periodically backed by Kafka Connect workers that are set up to back up the events to Amazon S3 buckets in case of disaster recovery, or even to facilitate batch ingestion. Note that the ETL service itself doesn't perform any batching of any sorts. It's solely real-time ingestion. Also, the resulting data ingested into Druid is null compliant and is mostly valid and sane. Now that we have all the data residing in Druid, how do we safely query these data sources for in a multi-tenant system? Like most architectures, we stood up a proxy between the client and the database layer. The diagram here shows an overview of our query layer, ignoring the nitty-gritty details. All API clients make requests to a backend via proxy, and they using gRPC. The gRPC APIs are modeled to embed SQL-like syntax to give enough flexibility to the user. But also note that the external users cannot straight up perform free-form SQL queries directly against our clusters for security reasons. The proxy applies domain-specific knowledge and performs semantic validation on the incoming request. If a request is deemed valid, it is translated to a Druid SQL query, which is then forwarded to the Druid broker through a load balancer. Note that in addition to using authorization and authentication techniques, following this method of performing semantic validations with strongly typed gRPC-based APIs make this proxy layer safe and secure. Now let's look at a very contrived Druid SQL query example here. Let's say I, as an API user, would like to query the customer's data source for all purchases made by a customer called Alice. If you look at the results set closely, we'll notice that records for another customer called Bob is also being written. Obviously, this is bad. If you look more closely at the Druid SQL query issued, you'll notice that I've used SQL comments to invalidate the latter part of the query in the where clause. So as an evil API user, I was able to handcraft a SQL injection vulnerability here. This is bad, obviously, because of leaking private and confidential information. Of course, this is a made-up, contrived example just for illustration purposes. But in general, how do we prevent such SQL injection attacks in a system, in a multi-tenant architecture? One simple approach would be to properly quote and escape query literals. I believe the Druid documentation has some recommendation guidance on this. But thanks to Druid committers with 0.18, that is an even better solution, parameterized queries. With parameterized queries, we can now replace any literals with placeholders, question mark placeholders, and the values can be supplied as query parameters. These parameters are dynamically bound to the placeholders at query execution time. You could also check out the pull request 6974 on the SQL support for dynamic parameters. Once 0.18 is rolled out, we plan to integrate with this feature to complement our domain-specific semantic validations in the context of issuing safe queries. So now that we've seen the proxy at a high level, how do we, in general, build a general purpose API, a proxy that API users can flexibly use without a lot of churn from backend developers? Also, how do we tackle schema management at large? How do we make sure that the different schemas and different environments are in sync and always forward compatible? Hand coding or manual inspection and managing these manually for both of these questions would be extremely cumbersome and error prone. Also, it's worth noting, worth considering if we are okay with dealing with some performance penalty when it comes to using, like, say, reflections to pack and unpack objects while interfacing with Druid. So how do we tile all these things together? So while exploring through different solutions, we found that code generation seemed like a good fit for us. So from a single configuration spec file, a tool spits out different entities ranging from the Druid ingestion specs to protocol buffer schemas needed by the proxy, ETL application, and so on. The Druid code gen spec is sort of our holy grail to do schema management with respect to Druid. It is a single source of truth that developers have to maintain and define. The generated strongly typed interfaces are sort of self-documenting. It helps with one of our primary goals of issuing safe queries by significantly reducing the attack vector. and also aids with semantic validations one can perform. Now we can also go back in time and trace what was ingested at any given time. Also, more broadly, it helps with auditing and compliance checks. This gives us like fine control on what dimensions and metrics are exposed internally versus externally, and so on, without having to jump through multiple hoops. Also, the code gen process has found to be improving developers' productivity. Folks can just rather relatively quickly add a new feature, or even like extend an existing one by making a simple few changes to a single configuration file, and the framework integrated into the CI process takes care of the most part, for the most part. Most of you are probably aware that schema validation on its own is a nightmare. In an ideal world, new versions of backend systems should maintain backward compatibility for as long as older services need it, but that's often not the case. So we introduce schema validation checks in our CI/CD process. Now we take these generated protobufs and run through a set of defined rules to detect breaking changes or backward incompatible changes. This is, as part of our CI process, has been very helpful in detecting mostly unintentional backward incompatibility changes introduced. In the interest of time, I'll defer the details of this process to the Druid Summit. So to wrap it up, these are some of our experiences and lessons learned. To reiterate some points, code generation has been particularly very helpful for better schema management, issuing safe queries, avoiding performance penalties, as in the case of reflections in the query's critical path. Of course, there's no single silver bullet. Depending on your use case patterns, your query patterns, a different solution might also work. I would also like to highlight a few other lessons that we learned during this Druid journey. Some applications in particular require null compliance, basically to discern the fuzziness between null versus zero. This is particularly important when it comes to using count and average aggregators and so on. We plan to enable the SQL null handling feature in our Druid clusters once 0.18 is out, which has a fix to preserve null values post-compaction. We had a patch that was contributed upstream in this area. Note that there is a small overhead in terms of storage and lookup while enabling this feature, but for us, that seems acceptable. There is also a good blog post that runs through, that's done from the Imply folks that shows some experimentation on the cost in different scenarios. Also, to avoid any surprises, all applications in the pipeline observe and stick to a single notion of timestamp, which makes it really easy to reason about or debug, troubleshoot, and so on. Since we use protocol buffers, the Google protobuf timestamp automatically enforces UTC time. In addition to tests, enforcing linters and schema validation checkers in the CI process has been helpful to maintain good code and schema hygiene. It also helps reduce the onus on code reviewers and developers in the long-term development lifecycle. I would also like to emphasize some points and validations, particularly enforcing sanity checks on invariants in the system, be it on the ingestion side, the query side, or any piece of the system. It helps avoid, it only makes sure that only valid known sane data is ingested into the pipeline and helps avoid expensive batch re-ingestion jobs for fix-ups. Like some of the previous talks mentioned, building instrumentation and applications to track and signal any unexpected conditions could go a long way. This includes employing a variety of techniques such as tag logging, metrics, setting dashboard alerts, and to alert on unexpected conditions, and so on. With that, I'll hand it over to TJ. Thank you.
Cool, thanks, Abhishek. Let's see here. So just to quickly wrap up here. So just general lessons learned. So having worked on kind of data-driven products for a while now, I think one of the, in addition to kind of like all of the good real-time ingestion and performance reasons for selecting Druid, another really has to do with getting a system in place that allows you to quickly evolve your data model in a performant way. So prior to Druid, you would see a lot of systems designed, and I designed one of these systems myself, in which you would aggressively try to figure out exactly what queries you wanted, what your data model was, and optimize exactly for that case. And then you would see like, okay, your product has been out for a couple months, and now, of course, people want to see something more. They want, filtering on a different dimension or new dimensions added. And so to actually change your data model then in this highly specialized system becomes very expensive from an engineering perspective. But if instead you run with Druid, because Druid is generally extremely performant, and it makes it extremely easy to modify your schema to move it along, you can simply deploy Druid and then have your data model evolve naturally as you learn more about your product, your users, and the data itself. Next slide, please. Let's see here. So Kafka ingestion. So prior to Intersight and Crosswork Cloud, I mostly ran ingestion with Tranquility and a combination of Tranquility and Samza. And that worked really great. This was in production for 3 years. But the thing was that we had to have a pretty traditional Lambda architecture in which real-time data with recent data was ingested in real time, and then any late data, and for our application, we actually had like a fair amount of late data, it would get picked up in a daily batch re-ingestion job. So that's all good, but now that we have Kafka ingestion, we actually can get late data. And this is really fantastic because for many applications then you might be able to just get away with having Kafka only ingestion and not deal with batch re-ingestion jobs. We did have a bug, and I'll just tell a quick story here, where our pipeline was just sort of like re-admitting old duplicate data. And this data was like just these little tiny packets of data just smeared over a long period of time in the past. And so that ended up generating a ton of small segments. So we solved that problem with just turning on auto compaction, which works totally fantastic. You should be doing this anyway. But because it was actually legitimately duplicate data, then we would run batch re-ingestion jobs to actually dedupe the data. So I guess what I'd say, the lesson learned is that for the most part, you can get away probably with doing Kafka ingestion for real time, but because Druid has the flexibility of doing large batch re-ingestions, whether with Hadoop or native, you can fix up your timeline. So it puts you in a really, really good position. And then the last thing I'll close out with is just, having run Druid in production for about 5 years now, I'm really happy with the quality, the engineering quality of this as an open source project. Definitely I've used a lot of open source frameworks. Most of them are quite good, but Druid really stands out, I think, both for the community as well as just the general quality of the system. And I've done a lot of dumb things in in production with Druid, and Druid for the most part has like survived it well and clearly said, no, don't do this, and we were able to route around it. So thank you to the Druid committers, and definitely thank you to Imply for organizing this. And so I think we'll stop there and take questions.
Wow, thank you very much for that nice vote of confidence. It's good to hear that it told you that you were doing something wrong. That's important. We've only got about 11 questions, so please, anybody else who's got any other questions for TJ or Abhishek, just please feel free to ask in the Q&A down there. The number one question, I think it was asked 7 out of the 11 times, is: are you guys planning, or is the CodeGen code open source?
Not at the moment, but yeah, we might in the future.
Yep.
Well, you seem to have a lot of interest in that particular thing. And does it map Kafka Avros schemas? Easy for me to say.
No, we don't use Avros. We only use protocol buffers. So only that is supported, but yeah, for internally only that is used for now. So that's the only relevant piece.
Okay. What didn't you like about Foundation DB, or what was keeping you guys from moving forward with it?
I mean, I think the main issue there kind of touches on what I was saying about data model. So Foundation is a really fantastic database, to be absolutely clear, but it is very low level. So you need to be very careful about if, for example, you want to add a new dimension or you want to index over a new dimension to allow fast filtering. You basically have to hand code that yourself and also worry about whether you do the same thing for past data as well as for future data. Basically, all of those problems can absolutely be solved through code and engineering time, or you can simply use Druid and never have to worry about that. So I think really it's just that, I mean, for time series data, Druid is a more appropriate database. We still actually use Foundation for a lot of things, just not for the time series piece.
Yeah, well, I'm definitely a big advocate of, when you've got so many different open source options, you use the right database for the right use case, right? What is your ETL app? So we saw that in the reference architecture earlier.
Not sure I fully get the question here.
Well,
so what are you writing your ETL in? So you have a Kafka to, if I remember correctly, Kafka
Yes.
to and some sort of ETL process?
Right. So we started out using kind of a Golang stream processing framework, but things have actually kind of evolved to the point where it's mostly kind of like an in-house Go stream processing framework.
Right.
Excellent. Number one ETL tool on the planet is hand coding stuff. What's your ingest layer before Kafka?
I guess it's kind of the same answer, right? So we basically, I mean, so for example, for the network monitoring for CCNI network insights, a lot of the data that we collect is duplicate data. So we have kind of like a deduplication layer, and then we have a layer that takes just the change log and does alerting. So customers express certain conditions, parameterized conditions around what they consider to be something they want to be alerted on, and then this layer will generate the alert, and then that goes to like a delivery layer. So it's again, we're not really using something off the shelf. Rather, we're using the Go stream framework that we have, and then just individual application layers in the pipeline from that.
So then what about your front end tools? What are you using to visualize all this?
Okay, so yeah, basically that is actually all just in-house developed, and we develop in TypeScript.
Ooh, all right, so lots of questions about multi-tenancy. So let's see, major challenges of running a multi-tenant Druid cluster, and do you do it with data source per client, or do you do it at storage level? Can you talk a little bit about how you guys implemented that?
Yeah, absolutely. So this kind of goes back to what Abhishek was saying about the secure proxy layer. So at this point in time, we actually don't do data source per client. Rather, it is a truly multi-tenant database. So our data sources are multi-tenant, and then obviously every query that has any notion of private data then must have the appropriate filters to prevent any kind of bleed through. It's also important to note that for a lot of our data, like the internet routing data, that's actually basically public data in some sense. And so it's kind of interesting in that some of our data sources do have kind of like a multi-tenancy aspect, but then others kind of don't.
More about the size of your cluster and how much data you are storing in your cluster, more about scalability. So tell us
okay. Let's see. So for the network insights piece, that's probably our highest scale. That is like, average, let's say like 5K events per second, spiking up to like 20K events per second. So as you know, it's actually, as of right now, definitely not on the higher end, certainly nowhere near like the systems described at Twitter. But as our product continues to evolve, we will take more data sources from around, so basically add more peers to the system, and then that will also, you know, create like a pretty large scaling. So it's, you know, obviously one of the other really attractive things about Druid is just the ease of horizontal scaling, and that our data is kind of naturally partitionable.
For internal users, are you guys using any type of cell level security? So row and column level masking or access control using something like Apache Ranger or another tool?
So we actually do not. So we basically solve this problem by not really having a lot of internal users having access to the database to begin with. So no, to be totally frank, we don't use any tools that provide row level security at this point. Definitely, if we opened it up more broadly to users, we would absolutely, you know, have to do something like that. But probably it would also actually run through the proxy that Abhishek described, because the proxy understands at a very fine level of detail, like which dimensions are sensitive and the kind of like the relationship between the querier and the dimensions. And so that thing would actually probably be in the best position to either authorize a query or just filter results.
Awesome. Well, thank you guys so much for your time and your attention. And it's been an absolutely fantastic session. Thank you so much for this.
Yeah, thank you.
Yeah, thank you guys.
All right. So, and thank you to all the participation. So we will be sending out a link to the slides in the recording. And as always, we would love to hear anybody on the phone story as well. So please send out an email to community@imply.io to find out more about future programs.